All right, welcome back today, guys. We're going to be doing lesson 9.1.2, how can I visualize it, involving nets and surface area. So yesterday we talked about volume. Today we're going to be talking about three-dimensional shapes and how to find area of each of those different surfaces. So can you picture what something will look like even before you see it built? Are you able to look at leftovers after a meal and decide what size container you will need in order to hold them? Being able to visualize what something will look like in a different form or shape is a useful skill that can be developed with practice. Today you will work with your team to visualize different three-dimensional shapes. Then you will consider the surface area of a box. Along with volume, surface area is another way to measure how large a box is. Before you begin today's lesson, read the math notes box prisms and pyramids that follow problem 9-23. So if you don't have a book, here is where math notes are going to look. You can go pause the video and make sure you guys read everything on here. There's going to be a lot of important books on the page, such as what is face and what is edge, what are these and what are bases. So again, go ahead and pause the video and read this, because these are terms that Ms. Lanza and I are going to be talking about with you guys throughout this lesson today. All right, so now you've read your math, go ahead and start with core problem 15. Your teacher will show you a card box, and Ms. Lando has one to show you. What was box is folded in 5 minutes. So all of us have had to take a box and flatten it out to take up space, take it to what would it look like? Look carefully at the box, discuss the possibility of the team. So for question 50, when we show you the box, you need to draw a picture or read what box looks like unfolded. So let's go ahead and start the box. So this is a rectangular prism. So notice that all of the sides are composed of rectangles. If you think about a gift box, a cereal box, a tissue box, all of those are pretty standard rectangular. So go ahead and draw or describe what that would look like if we unfolded all of the sides. So go ahead and take a minute, pause your video, and then we'll be back. All right, so Miss Lindsay went ahead and unfolded the shoebox that she had. Notice that, it's still composed of a bunch of rectangles, okay? And we want to think about what are some different sides that are similar to one another. So for example, this box, you're going to see the top and the bottom of that box are the exact same size. You guys are going to see the two rectangles here and here that make up the two sides are the same size rectangles. And these two rectangles here that make up the front and the back of the shoebox are again the same size rectangles. Okay? So we're going to keep that and use that information as we move on to the next core problem. So question 16 says, picture in your mind each of the figures below as three-dimensional objects. So again, it's kind of rectangular shoebox, box, cereal box. How would it look like if they were unfolded at each face or each flat table? A flat picture that can be put up in a three-dimensional solid net. Work with your team to draw nets for each of the shapes below. Listen carefully to its idea because there are more than one. So again, you guys have a team to work with today. So you guys have siblings, parents, or you're working on last week, so you compare what you guys are getting. Question A and B. So imagine again flattening this out. So if you took a scissors or a knife, cut at the center, what would you get on each side would lay down less? And pause video and draw what you think it may look. So if we look at letter A, again, it looks like a shot toy box. If we were to cut the seats here, so it looks flat, we cut here, here, and here. Okay, we get something that looks like this here. So notice that we have 4 sides. Okay, 4 rectangles here, okay, which makes up the 4 bases, okay, and we have 2 squares that make up the 2 ends here, okay. So we know that this rectangular prism has 6 sides, so we should know there are 1, 2, 3, 4, 5, 6 rectangles in our net. Now again, this is not the only way to draw this figure, okay. These 2 squares here on the ends can actually be in any of these locations depending upon where you slice the seams of this box. Okay, so you want to visualize this figure. If you had this base here and you folded these up, you now have the bottom of your box and the 2 sides, and then these 3 sides wrap around to form the rest of your rectangular prism. Now letter B may be a little bit trigger for you. Okay, there's a type of pyramid. Okay, and by their base. If you look at base, you have a 1, 2, 3, 4, 5, 6, you have a hexagon your base. This is called a hexagonal pyramid. Okay, it's called a pyramid because it comes to a point. All right. So first of all, you want to think of how different shapes compose pyramid. Meaning, this, like we had our regular prism, had 6 sides, so we expect to have 6 rectangles when we flatten it out. So a hexagon has 6 sides plus the base. So you should expect to have 7 different shapes when we flatten this out. So let's go ahead and add a hexagonal pyramid. And notice the base again is 6 sides. And each of these sides here have a triangle that is off of it coming up to a point. So again, you have your 1, 2, 3, 4, 5, 6 triangles that make up the pyramid and your one base. So 6 plus 1 is 7 different faces. Okay? So when you go ahead and deconstruct that, flatten it out real quick.
Like a banana. You peel.
So here are our bottom base, and you have your 1, 2, 3, 4, 5, 6 triangles that made up the sides of your prism. I'm sorry, pyramid. So here's a recap of what your answers would be for A and B. So here was your rectangular prism deconstructed and flattened. Okay, again with your 6 different faces. And here was your letter B with your base. That was a hexagon, and your 1, 2, 3, 4, 5, 6 triangles that made up the different faces. So moving on to 17. So now we're doing a visualization challenge. How much can you tell about a shape from its net? In this challenge, you must work with your team to describe each shape completely without building it. Use the questions below in the math notes box at the end of this lesson to help you make a complete description. Will the shape be a pyramid or a prism, meaning does it come to a point, or is it made up of all rectangles, or will it be something else? How many faces will it have? What shape is the base? What are the shapes of the faces, and how many of each does it have? When you're satisfied that you have described as much as you can, call your teacher to check. So obviously, again, you guys can't call us over, so we'll talk about each of these 4 nets individually. So go ahead and pause your video. I encourage you guys to draw these pictures, the different nets in your book. And then go ahead and describe what you guys can below each of these 4 nets. And then you guys can add on to what you guys have found. Alright, so go ahead and compare what you got with what Miss Lands and I went ahead and recorded for you guys. So net A is a cube. Notice that it's composed of 6 different squares. Okay, cubes are made up of 6 sides that are all squares. So all faces are square, and there are 6 of them. Net B, you guys see that it's a pyramid, okay, and again, because if our base here is a square, there's not a second square to be opposite of it, so all of these triangles come to a point. So it's a square pyramid with that base of a square with 4 triangular faces. Net C is a rectangular prism. So again, because it doesn't come to a point, all sides are either squares or rectangles. There are 6 total faces, 1, 2, 3, 4, 5, and 6. The base could either be this square or it could be a rectangle, depending upon how you orient it. And there are 4 rectangle faces and 2 square faces. Letter D is a pyramid, just like we talked about earlier. It is a hexagonal or hexagon base pyramid because the base is a hexagon. And you guys have there are 7 faces total, 6 of which are triangles and 1 of which is a hexagon. So go ahead and again pause the video. Make sure you guys add on to what you guys did put for yourself. And then we're going to go ahead and move on to question 18. So question 18 says, do you remember Carly and Stella from lesson 9.1.1? If not, you guys can always go back and refer to it. They were designing an office building and had come up with 5 different possible floor plans. The floor plans are shown again below. Okay. Carly and Stella want to make the lateral faces of the whole building entirely out of glass. So it tells you here what a lateral face is. These are the sides that are not the floor or not the roof. So pretty much the walls, the outside walls of your building and the interior walls of your building. How much glass will they need for their building? Assuming they use the floor plan your teacher assigned you and the height you found in problem 9-3, which is indicated below each plan, be prepared to explain your results to the glass. So we want to know how much glass we would need to do that many stories. So pause the video, try this on your own, because remember that, so for example, let's all do number 1 here, okay, 19 stories. This is the first floor. okay, or the first story, how much glass would we need? All right, so remember that a lateral side is not including the top or the bottom, the roof or the floor. So if we go back to our drawing that we would have done earlier in the week, we would have had this as our first floor building. So what you guys see here is really the roof of the building. What would be below that along the desk here is the bottom of, or the floor of the building. So we want to think about the glass is going to be the outside of the building, as well as maybe the inner part of the building, kind of like the courtyard, like we have courtyards here in school. So each of these sides, okay, are made up of 4 squares. So if these 4 sides, these 4 cubes, okay, these are glass, that has an area of 4, okay, and that means there's also an area of 4 on this side. All right, so 4 plus 4 is 8. We know that the front of our building has 3 squares, so we need 3 squared units of glass here. And we need 3 squared units of glass in the back of the building. So you guys can see that. So let's go ahead and label, where'd it go? There we go. So let's go ahead and label those the outside of our building. It's kind of like the perimeter, the area in the perimeter. So we have 4 units of glass over here, 4 units over here, 3 in the front, and 3 in the back. So 4 plus 4 plus 3 plus 3 is 14. But we also want to put glass in the middle in the courtyard of this building. So if we look at the inside, there's 2 panes of glass here, 2 over here, 1 over here, and 1 over here. So the inside, so go ahead, if you take a closer look on the inside there, we would need 1, 2, 3, 4, 5, 6 panes of glass in the middle here to fill it out. So the 14 faces in the front, on the outside of the building, plus the 6 in the middle, gives us 20 faces of glass that we need. So our very first floor would take 20 squared units of glass. So if we have 19 stories, we would take that 20, multiply it by the 19 floors to give us 380 squared units. So talking about squared units, that means we're finding area. Okay, we're not filling the entire cube with glass. We're just putting it along the outside and the inside walls. Okay, so we count up the area of our outside and the area of the inside where we're going to be putting glass, and we get 20 squared units. Okay, for our first floor. We multiply that by 19 because we have 19 of those stories to give us a total of 380 units squared. So if you didn't get 380, maybe some of you guys forgot about the middle here, okay, the courtyard. We're going to go ahead and have you guys try at least a couple of these 2, 3, 4, and 5, okay, and we'll come back and review with you guys the answers and give you guys a little bit of time to go ahead and work through those. So if you guys don't get the answers that we're giving to you guys, take a little bit of time and go back and look at them again. All right, so we did the first building plan together. If you guys look at the second story, the second plan here, we got that it was 384 units squared. So if you count the perimeter of this first story, you're going to get 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 4 in the middle. That's 16. Again, it's really just the perimeter because each of these represent 1 squared unit, okay? And then we multiply that by the 24 stories to get 384 square units. For number 3, the 32 stories, we're multiplying 14 by 32 because, again, if you find the number of panes that would take to do the outside of the building, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Question 4. would be 448 square units, and 5 would be 320 units squared. So again, make sure again you guys take the time to understand how we got those answers, how we got the what we were multiplying the number of stories by, and if you have questions, please let us know. So we're going to go ahead and move on to question 19. So surface area, this is a new term for us. It's just like finding area, but it's the area of all of your surfaces. So surface area is the number of squares it takes to wrap around the entire outside or the surface of a three-dimensional object, including the top and the bottom. So if we look at this rectangular prism, okay, it's just like a tissue box, it's got 6 sides, a top and a bottom, a front and a back, and 2 sides. So we need to find the area of all 6 of those. So this can be a little time consuming, but really we're finding 6 different areas and combining them or adding them together. So visualize wrapping the rectangular prism at the right with 1 centimeter grid paper. How many centimeter squares would be wrapped around the prism? What is the surface area? So go ahead and pause the video, and I want you guys to find the area of the front and the back, the top and the bottom, and the 2 sides, and add them together to see if you guys get the correct surface area. And we'll come back and talk about this here in a minute. So if we look at this rectangular prism, and we talked about deconstructing this or flattening it into a net, we know that there are 6 sides. There's a top and bottom that are the same. Okay. There's a front and a back that are the same, and we have 2 sides that are the same. All right. So I like to draw my just a sketch. It doesn't have to be real accurate. 2 rectangles that make up my top and bottom, 2 rectangles that make up my front and back, and 2 that make up my 2 sides, and put in the dimensions of those. So if I'm finding the area of the top here, it's 7 times 3. Okay, 7 times 3 is both the top and the bottom. The front and the back are both 6 by 7, so the area is 6 times 7. And the 2 sides here are 3 by 6. So again, the area is 3 times 6. When we multiply or find the product, we're going to find that the top and bottom both have areas of 21. The front and back both have areas of 42. And the 2 sides both have an area of 18. So if we want the area of all this, we're going to add them together. And if we add those all up, we get a total combined surface area of all of our surfaces of what?
162 centimeters squared.
So our units are still in centimeters squared because we're still talking about area. We're just talking about multiple areas combined together. So the question asked you about if you were covering this with paper, for example, wrapping paper, how much would you need? You would need 162 centimeters squared of wrapping paper to cover all of the 6 sides of this present. Okay, last question for today. Question: if nets in problem 917 were cut and folded to create solids, which solid would have the greatest surface area? Write down your team's prediction along with the justification. So first of all, your first step is to predict which one would have the greatest surface area. Then test your prediction by measuring the dimensions of your shape in centimeters, finding the surface area, and sharing your data with your team. Was your prediction correct? So what's your prediction? You need to go ahead and test your prediction by finding the surface area and then determining yes or no, is your prediction correct. So here were the 4 nets we had in question 17. All right. So again, surface area of net A is going to have 6 different areas. Net B is going to have 5 total areas added together. Net C is going to have 6 total areas added together. And net D is going to have a total of 7 areas added together. So go ahead and predict which has the largest surface area, and then go ahead and test your prediction. All right, let's see how you guys did. So net A has a total surface area of 150 squared centimeters. Net B has a total surface area of 174 centimeters squared. Net C has a total surface area of 198 centimeters squared. And net D has a total surface area of 100 centimeters squared. So
in order to get full credit for this, you're going to have to show your work of how you took each side, top, bottom, front, back, side to side, and how you multiplied it, and then you added it up to get the surface area.
So as a quick review, Ms. Lanza, how do we find the area of a square or rectangle?
Length times width.
Length times width. What about a triangle?
Length times, or 1/2 times base times height.
Okay. And letter D, you guys see a bunch of triangles and a hexagon. We talked about a hexagon is really just 2 trapezoids put together. So you may need to go back and look in your math notes about how to find the formula of a trapezoid, and then you would double it to find that of a hexagon. All right, great job today, guys. Make sure you guys review this lesson. Make sure you guys practice your homework and check your answers tomorrow, and we will see you tomorrow. Have a good day.